Hey guys, welcome back to another Algebra 2B video. This time we're talking about Lesson 9.6, Modeling Real-World Data. A pattern in data can suggest what type of model is going to fit that data. Now, not always is it going to be exact, but when it is, you know for sure you've got this type of model. The first one here is a linear model. Linear models, we did these back in Algebra 2A. If the first differences are constant, you have a linear relationship. So here, 27 minus 12, 42 minus 27, 57 minus 42, and 72 minus 57. Those are all 15, right? So this means that this data is linear. And we could use a linear regression to figure out the line of best fit. Or all we need to do is find the slope and use point slope form, which we've done in the past. If the second differences are a constant, then if you think back again to Algebra 2A, we have a quadratic model. That means if the first differences are not a constant, they say try the second differences. So here, when we did it, we got 15 minus 9 is 6, and 23 minus 15 is 8, and 33 minus 23 is 10, and 45 minus 33 is 12. Those are not constant. But if I do it again, 8 minus 6, that's 2, 10 minus 8 is 2, 12 minus 6 is 2. This would be quadratic. And I could use a quadratic regression to figure out the quadratic equation, or the curve of best fit. Now, if the x values are evenly spaced and the ratios of the y values are constant, then you probably have an exponential model. So what they're saying here is if the first and second differences are not constant, try looking at the ratios. Really, you could try looking at other differences, but let's just go with it. So here what we have is 100 minus 40 is 60. 250 minus 100, 150, 625 minus 250, 375. Find the differences again, they're still not anywhere close. One other hint here that you might want to look at is look at how big y is getting. X is going up by 1, but y goes from 40 to 625 in a matter of 4 data points. That's probably exponential. Although you still should check those differences to see if they are constants. If they're not, check the ratios. 100 is to 40, that's 2.5. 250 to 100, 2.5. 625 to 250, 2.5. So this is exponential. Now, if the y values are evenly spaced, this is the new thing. If y values are evenly spaced, I should say, the second differences are constant. For x, if the y values are evenly spaced and the second differences of the x values are constant, you got a square root model. So notice here that the y's are going up by 1, 3, 4, 5, 6, 7. So I'm going to look at the differences in my x values. And if I find those second differences, I find that they are all 4. So this is probably a square root model. So how are we going to do this? Got to find those differences. You're going to need a calculator, and you're going to have to just do some subtraction here and see what happens. So let's see. If I do some subtraction on number 1 here, 26.6 minus 22.3, I get 4.3. 30.9 minus 26.6, guess what that is? 4.3. And 35.2 minus 30.9, guess what? 4.3. 39.5 minus 35.2, 4.3. Now, why did I not just stop after the second time? Because I got to make sure they all are. These first differences are all constant, so this guy is definitely linear. Let's look at number 2. Here's a big hint. Look at y. We're going up by 1. So let's look at the differences in the x's. 41 minus 32. is 9. 56 minus 41 is 15. 77 minus 56 is 21. And 104 minus 77 is 27. Now, remember, it's not the first differences that have to be constant, it's the second. So 15 minus 9 is 6. That's a 6. Really. It's a 6. I don't know what you're talking about. Totally a 6. 21 minus 15 is 6, and 27 minus 21, that is 6. So our second differences are constant. So this guy here is a square root function. All right. Now you probably know what we're getting at here, but after you determine what your parent function is, you can use the regression feature on your calculator. Regression feature to find a function that models the data. So if we look here, they gave us some data. Are my x's evenly spaced? Got to make sure. Now they don't all have to be this, they don't have to go up by 1. They could go up by 4. They could go up by 3. You just got to make sure that there's a nice even progression there for your x values. And then you're going to look at the y's. Well, they looked at the y's and they found that, unfortunately, the first differences here, they are not the same. So we look at the second ones. Oh my God, they're not the same. So let's look at ratios. Look at what our ratios are. They're all pretty close to 1.3. They're not exact. And in real world data, it's going to be rare that you're actually exactly exponential or exactly linear or exactly quadratic. But the fact that the ratios are pretty darn close to 1.3 means we're going to use an exponential model. So what we do is, like they said right here, you're going to go stat edit, and that is you're going to use L1 and L2 to enter your lists, and then you're going to do stat calc. And you're going to figure out which one you need. Now, for this one, they said exponential regression. You might use linear regression. You might use, quadratic regression for a quadratic function. You could use exponential regression, like we talked about. You could listen to the bell ring. I do not believe that the graphic calculators have a square root regression feature on them. So square root regression is not going to happen. Well, I suppose you could use an exponential regression for a square root and just look for a exponent of 0.5, but let's not worry about that right now. These are the three you're probably going to be focused on. And yes, this is another reason why you're going to need a graphic calculator at home if you don't have one. You can use the app, but with the graphic calculator apps, even the ones that I've shown you guys in class, it's a little tricky. You're going to have to probably Google how to actually figure it out because it doesn't work exactly the same way as it does in class. But anyway, this one is, as we said, the ratios were all right around 1.3, so it's exponential. And so here we go. We got A is 24.8. That's your constant. And then your power is 1.3, pretty much. And the R value, that's pretty darn close to 1. The closer you are to 1, the more exponential it is. And it doesn't get much closer. I mean, it could be equal to 1, but it's pretty darn close. And we saw that because all of these ratios were pretty darn close. They were within, like, 1/100th of each other, so that's pretty darn good. All right, so let's take a look and let's try to figure this out. Now, I'm going to use my calculator. There's a big hint here. Look at, are the second differences a constant? So it's probably going to be quadratic. I'm going to use the calculator. I can't show you the calculator, unfortunately. I'm sorry. I don't have a calculator on my screen, but you can follow along with your graphic calculator at home if you do these things. These are right here. Just do this, and you should be able to figure it out. All right, so first of all, are our x values evenly spaced? Yes. We're going up by 1. What about the y differences? Are they a constant? Well, let's see. 56 minus 33. 56 minus 33 is 23. 86 minus 56. All right, they're already not a constant. 30. I still need them, though, in case I need to look at other differences. So 123 minus 86. 37. And 167 minus 123, 44. Okay. Are they constant? No. Let's look at the second differences. 30 minus 23, that's 7. Hey, 37 minus 30, that's 7. 44 minus 37, guess what? That's 7. So the answer is yes. So this is a quadratic. So we are going to do quadratic. But before we do that, we have to do the, oh, well, all right, yeah. Might as well put the answer where it belongs. Quadratic. And what would it be? So I'm going to do stat edit, and I'm going to plug in, there's L1, and there's L2. So I'm going to do that right now. Let's see, what do we got? We got 3, 4, 5, 6, 7. Oh, people are going to be late. All right, and then 33, 56, 86, 123, 167 in L2. Go back to stat, go to calc, stat, calc, and we want quadrag. It's option number 5, quadrag. So I'm going to do option number 5. I'm going to hit enter, and this is what I get. I get A is 3.5, so 3.5x squared. B is negative 1.5 minus 1.5x. C is 6. I get plus 6. That's the quadratic model that fits the data. I'll even put in a y equals there, just for fun. That's it. And I know I really don't... The bell. I don't like giving out these kinds of assignments at home when I know it's calculator intensive and some of you don't have one. But this is kind of the way things worked out today, so I'm sorry. I will make sure when I see you guys are in, and if you're in cohort B, you're in on Wednesday. If you're cohort A, you're in class, so you'll see this in class. It'll be fine. If you're at home and you need a graphic calculator, like I said, find a graphic calculator app. I found a link where you can plug this stuff in online, and it'll create the regression for you. And I will post a link to that in the lesson. So anyway, there it is. I hope you learned something today. If you did, smash that like button and subscribe. Come on. What is more fun than listening to me write out the math notes for you? I'm sure you guys are watching these every day. You should be. Really. Please. Watch.